Welcome to EDU World Space.
So the three protons form an equilateral triangle. So I'm going to go ahead and draw a little diagram to help us better understand this problem. So these dots actually represent the protons, and hold on, let me draw a third one. And as you can see, these three protons have formed an equilateral triangle. Let me just draw the radiuses between the two to help you better understand. So let's call this distance r. And since it's an equilateral triangle, the radius is the same for all of them. So let me just label the charges Q1, Q1 to Q3, Q1, Q2, Q3. All right. So now we know the radius is equal to 2 times 10 to the, hold on, let me rewrite that. We know that the radius, which is given to us, is 2 times 10 to the negative 15 meters. All right, so obviously this is a very small distance, but it's also important to note that the distance between all the three charges are equal to the radius and are constant for all of them. So now to find the total amount, now to find the amount of work for one done by one charge, we know the equation is the amount of work is equal to Coulomb's constant times charge 1, charge 2 over the radius separating them. So this is the work done between the two charges. So if you have three charges, there's a total of three different exertions of force. So we must add the total weight, the total work done. So if you were to add the total work done, and since the charges are the same, the radius is the same, we can just multiply this value by a constant of 3. And again, since the charges are the same, we can just make it q squared, since charge 1 and charge 2 are the same thing. So q squared times 3, these are brackets, over the, hold on, the radius is also included in the brackets. Here, let me get the eraser going. Yeah, let me just start over. All right. So 3 times Coulomb's constant times the two charges, so q squared, over the radius. So this is the total work done. And now if you were to just plug in the constants that we have, so Coulomb's constant, which you all know is 8.99 times 10 to the power of 9 Newton meter squared over Coulomb squared for the units. So 3 times 8.99 times 10 to the power of 9. And then we know the charges for the electrons are 1.6 times 10 to the power of 19, negative 19. So these are the charges, and we know that this whole thing is squared because there are two charges. So let's just square this. Hold on, let me get that a little bit. Let me write that a little bit nicer. So negative 19. All right, and then over the radius, which we already said was 2 times 10 to the negative 10. All right, so this is the final equation. Hold on, let me write this a little clearer. So it's 10 to the power of negative 15 over here. Sorry, it's not very clear, but yeah. All right. So if you plug these into a calculator, we'll get that the work is equal to 3.452 joules. Now, if you want to convert these into mega electron volts, MEVs, then we have to just divide this by 1.602 times 10 to the, sorry, hold on. This was 3.452 times, sorry, I'm forgetting a couple digits here. But yeah, so this is 3.452 times 10 to the negative 15. So if you want to convert these into MeVs, then we just need to divide by 1.06 times 10 to the negative 13. If you do that over here. So if you plug this into our calculator, we're going to get that the total number, the total work in MeVs is 2.16 MeV. Yep. So it's equal to 2.16 mega electron volts. EV. Yep. So that's it. Thank you for listening.